Stan Gibilisco here to explain the operation of a weak signal field effect transistor amplifier and to show how the signal flows through this field effect transistor. It happens to be an N-channel device to produce amplification. You put a weak signal, it need have very little current, just a little bit of voltage will do the trick here. R2, the resistor, and C2, the capacitor, serve to allow for the input signal to reach the gate without being shorted out to ground. So the input signal voltage appears at the gate of this transistor, and it can be a very tiny voltage, but because of the configuration of this circuit, that tiny voltage at the input can result in a quite large voltage at the output, provided that you use the correct values for R1, the resistor, and C1, the capacitor. The capacitor, in effect, grounds the source of the field effect transistor for signal, but it's not a direct short circuit. It grounds it for the purpose of signal. R1 provides the correct voltage bias with respect to ground along with R2, so that a very weak signal, a very small change in voltage at the gate, will produce a very large change in the current through the device from the source, that's here, to the drain, that's here. And that current is limited by resistor R3. In this case, the power supply bias voltage is 12 volts. So you get a very large fluctuation in the current through this resistor R3. When you place a capacitor in series here to block the direct short circuit, prevent this drain from being shorted out to ground, what you in effect get is a large change in the voltage. You don't get any current because the capacitor in effect blocks that, but you get a very large change in the voltage fluctuations at the output. So that's how a circuit like this works. You get a small change in the voltage at the gate, produces a large change in the current through R3, the resistor, which in turn produces a large change in the voltage at the output, provided that the output has a high impedance. If the output has a low impedance, you're going to get a much lower voltage and might not get any amplification at all. So a small voltage change here produces a large voltage change here. So a weak signal here produces a strong signal here. Again, resistor R2 serves to provide the correct voltage on the gate without being shorted out, without shorting the signal out to ground. R1 and C1 provide for the proper voltage at the source for the maximum possible amplification, that is, change in the current through the device, which then results in a large change, large fluctuations in the voltage across R3 and a large signal at the output. And by large, I mean maybe a very, very small fraction of a microvolt here and possibly several millivolts here. This is a receiving circuit. A viewer wanted me to explain the way that signals flow through amplifiers, and I'm doing the best that I can. I'm explaining the function of each component as I go. So hopefully you made some some understanding out of this. The characteristic of the field effect transistor is that a small change in the voltage at the gate can produce a very large change in the current through the device, provided that the values of these resistors are correct. And you generally have to figure those out by experimentation. We are radio amateurs, well, some of us are, electronics hobbyists, and part of the fun is optimizing circuits like this. Stan Gibilisco signing off. Until next time, so long.